Alright, Kia, here's another scenario here. So here we have, or at least we have another concept, straight line depreciation and compound decay, right? And I saw that in the notes provided, straight line as well can be called straight line. Sometimes it can be called straight line depreciation, but sometimes straight line basis, right? I saw there, and also sometimes compound decay can be called reducing balance or reducing basis, so just depending on the wording. So it's very important for you to associate straight line depreciation, also straight line basis, something you need to be familiar with. Formula for straight line is 1 minus I times n. So very important, this is not simple interest, but it is straight line depreciation. Okay, remember, depreciating means when certain items basically go down in value. That's when they go down in value. Depreciation down. Okay, yeah, so that's very important. So the negative is featured in the formula, whereas compound decay or reducing balance basis has this formula: A is equal to P1 minus I to the power n, the n outside the bracket. So you just need to make the distinction. Let's look at a question here. It says the value of a front loader depreciates by 9%. So this is an item that's going down, okay, and 9% per annum over 4 years. If the loader costs 350,000 initially, how much would it be worth after 4 years if depreciation is calculated on a straight line basis? So first and foremost, what's important here is to be able to know that straight line basis. Okay, since we are talking about depreciation, we're going to say 1 minus I times n. Very important. Then you need to collect all your important variables. Okay, A, P, I, and n. And remember, it says the value of a front loader depreciates by 9% over 4 years. So 9% would be the interest rate, but remember, I is the interest rate as a decimal number. So this is not comma not 9 if we take 9 and divide it by 100. N over 4 years, so that means 4 years. Now it says if the loader costs 350,000 initially at the beginning, remember P, present value at the beginning, so 350,000, right? How much would it be worth after 4 years if depreciation? Now that's the thing, that means this amount will be going down, right? Because there's this word depreciation. If depreciation is calculated on a, furthermore, we know that it's depreciation because they say straight line basis. So there are two things that are confirming that we are dealing with depreciation, but also depreciation the straight line kind, because it's 1 minus I times n. Very important. So we want to calculate the a value, very, very importantly. So we write down the formula first and foremost. We collect our variable items A, P, I, and N, very importantly, and we make sure that we write these variable values in the right place. Imagine we don't want to be writing this there, right? We want to make sure that we got the scenario. If it says initially, then it means this is the beginning amount, the present value amount. Okay, then after a number of years, after a number of years, very important, after a number of years, the future value, very important, the a value, P, 350,000. Okay, make sure that you write down the amounts correctly. You know, the last thing you want to do is write down this as 35,000. Make sure that you always verify and check that, okay, in the question paper, this amount, does it have 1, 2, 3, 4 zeros? It still has 1, 2, 3, 4 zeros. You know, those are things that sometimes we make a mistake of and we lose marks for no reason. I is equal to 0.09 times n is equal to 4 years. So I'm going to do that, quickly paste this and find this out in my calculator. Okay, so 1 minus not cancel not comma. Okay, so I'm just gonna punch this in the calculator quickly, sorry. So it's 0.64. So you would be able in your scientific calculator to just punch all of this in your calculator, right? Yeah. Yeah, and since we are dealing with straight line basis, if you look at this amount, you can see that this is a lower amount, which it's supposed to be, because like we said, the front loader is going down in value over 4 years. Why? Because remember, we are using that item, so the more you use that front loader, because front loaders are used to basically wash clothes, the more you use it, wear and tear, gets the better of it. Now we've calculated the amount for straight line basis. Now we need to calculate the amount for reducing balance basis, which means the formula is different. A is equal to P1 minus I, but to the power n. Okay, very important. It's not plus, but it's minus, because we are talking about depreciation, reducing balance. Okay, those are things that you need to be aware of when you are doing your calculations. Okay, so we are still dealing with the same item here. Okay, just different formula. Okay. Right, so I'm trusting that you will be able to get that amount. Right, in the comment section you can kindly tell me what that amount is, and that would be really appreciated. I think all of you guys can actually do that for me. I'm gonna leave that amount open. Okay, but I hope we get the gist of what we're doing whenever we're dealing with compound depreciation, or simple straight line basis, or straight line depreciation. Let's look at this one. Aiden purchased a car for 145,700. It depreciates at a rate of 5.7% per annum on a reducing balance basis. Okay, calculate what the car will be worth in 7 years time. So once again, what are we dealing with here? Depreciation, but what kind? Which formula will we be using? All right, this is a question that I'm going to allow you to do on your own, but you should be able to do it, right? Remember, it's an identification of all of our variables. What is that? Is that A or P? All right, because we're dealing with depreciation at a rate of 5.7% per annum. What do we do to the interest rate as a percentage? What do? We need to convert it, right? Reducing balance basis, which formula does this speak to? Is it A is equal to P1 minus I times N, or is it A is equal to P1 minus I to the power N? All right, very, very important. All of these things are very, very important. So I'm going to allow you, you can pause the video, you can stop right there, you can do the calculation, and then in the comment section you can let me know what you got, right? Which is very, very important. Okay, just gonna turn over the page. Let's look at this question. This question is slightly different. It says Megan purchases a car at the end of 2013. Okay, the car depreciates at a rate of 8.3% per annum on a reducing balance basis. Very important, reducing balance basis. At the end of 2018, the car is worth 112,000. Calculate how much Megan paid for the car when she bought it. So I'm just going to do this one very quickly. So first and foremost, what did we learn? Reducing balance basis. So which formula does that speak to? 1 minus I to the power n. Very importantly, let's collect all of our data from the question. Very important. So A, first and foremost, do we have the A value? Yes, we do, because we are told here that the car depreciates at the rate of 8.3%, right? Do we have the A value? No. Megan purchased a car at the end of 2013. The car depreciates at the rate of 8.3% per annum on a reducing balance basis. At the end of 2018, the car is worth 112,000 at the end of 2018, which means in the future, right? This is a future value. This is after a number of years have passed. The amount is 112,000. So very importantly here, we don't have the P amount, the present value, the value that it was initially or at the beginning, right? So that means we want that now this time around. So let's calculate how much Megan paid for the car when she bought it. Remember, when she bought it is at the beginning. So it's what we want, the P value. We don't have it this time around. So this is how this question is slightly different. I is equal to the interest rate as a percent, as a decimal. So we're going to take this 8.3, we're going to divide by 100, okay, and we're going to get 0.083, then n. Now, very interesting, we are told that the Megan purchased the car at the end of 2013, and then at the end of 2018 the car is worth this amount of money. So we're calculating from 2018 at the end minus 2013 at the end, which means that's a total of what? Of 5 years. So we say 2018 minus 2013 because they specifically said at the end. So at least it's from the end of 2013 to the end of 2018. So that's a full 2018 minus 2013. We can get the full 5 years. That's a full 5 years, right? Because from end to end, so 5 years. Very important, right? So yeah, some questions require us, they don't tell us explicitly the number of years. We need to figure out what the number of years are based on the situation. Then from here on, surely from here I shouldn't have to actually do the calculation. So I'm also going to leave this one hanging. All right, but that's what we do. And remember, for our next step, we want P to be isolated, right? And the P is multiplied to the bracket. So what we do is we divide, okay, both sides by what we see in brackets. Okay, yeah, and obviously this would lead to this cancellation. That means P will be isolated. We just use our calculator and punch that in, all right, and we should be able to get the amount. So once again, I'm going to leave that, and then in the comment section, you'll let me know Megan bought the car initially for how much. All right, so you just put this all in your calculator. All right, scientific calculator should be able to house all of this. You just make sure that you use you select that, and then you punch in at the top the 11,200. Sorry, the 11. What is this? The 112,000. Why am I saying 11,200? The 112,000 rand over. Then you put the brackets 1 minus 0.083 to the power 5, the exponent 5. You just press equal, and then you tell me what that um, yeah, amount is. Okay, right.